So I'm really happy to be here. So first thing is to thank the organizer who put a lot of work into this, and also all of you who make this a magical place. Slides are on GitHub, kind of easy to find with given the title of the talk. And the talk title is oh, nice, sexier. The talk title is Nimib for Pythonistas, and the idea is the talk is not only to talk about Nimib, but also about being a Pythonista, possibly a better Pythonista through Nimib in this case. So, what is Nimib? I don't know how many of you have heard about this before deciding to come to this talk or not, but Nimib is a programming language, which makes it a bit awkward because we are at a PyCon, which is a conference about a programming language, although I would argue it's a bit more than a programming language, Python. But bear with me. So first, it's a systems programming language, which means it's the kind of language that you can write a kernel or something like that. So it's a language in the same area in terms of power as C, Rust, or Zig, which, if you look at the code above there, you would say, but no, good systems programming language have braces. Why this doesn't have braces? Looks like Python, but it is different from Python. Although you're not seeing types here, this is actually statically typed and compiled, which I would say now it makes it a little bit more interesting because now we are out of our comfort zone, and this is one way of learning things. What can you do with it? Well, it's kind of good for everything. Some languages are designed with specific domains of use cases in mind. This was not really. I will not talk too much about what you can do about it, but that's the idea. So, I'll have to give a little bit of context about Nimib, about me, sorry. So first, I am a data scientist, kind of recovering. I worked a few years as a data scientist. But before that, back in the 90s, I was a Pythonista. It was the first language that really clicked for me. I really loved it at the time, and I still love it. In between, I decided somewhat to study mathematics, which made me do other things like MATLAB or other things. And recently I've been involved with the Python Milano community, and we launched a PyData chapter. So if you're curious about how to launch a PyData chapter in Italy, come talk to me later. But before doing that, and in a weird twist strangely related to this will of involving myself in a community like Python, almost 6 years ago, I ran into this article on HN about a programming language underdog, which, of course, it was Nimib. And since I was kind of a sucker for underdog stories, I looked it up, and I find it really fascinating. And part of that fascination is what I want to talk about. Finally, part of this talk was prepared while at Recurse Center, which is a delightful place to become a better programmer in company of kind and interesting people that are doing the same. So look it up if you're interested and ask me about it later. So let's come to the topic of the talk, which is, as I mentioned, not really about Nimib, but taking Nimib as a use case. And the idea is, how can I one way to become a better programmer is to learn a new language and do things in a domain you're not proficient of. So, data scientist, system programming, kind of two different things. Still, languages are kind of hard sometimes to say, okay, especially if you like a language like Python, to say, okay, you can't have an identity crisis when writing in another language and starting to write in another language. So let's first do a little bit of therapy, which is always useful. And first, I want to talk about 3 things I like about Python, and these 3 things I think will be are 3 things which in my opinion, are also shared by Nimib. And one of these is accessibility. One of the things I love about Python is how everybody can pick it up, and it's very accessible, it's welcoming for everybody. And it's probably one of the most accessible languages out there. The second thing is playfulness, which is a very important value. And playfulness, I think it's very important when you live in a very dynamic environment, when you grow up and you have to learn a lot of things. So I think it's not an accident that Python is very used in data science or whatnot. So in this realm where everything changes so fast, and you have to play games to learn stuff, like my daughter does. And the other thing that I like about Python, that is good for everything. It's the second best language for everything, which has an implication, which means that at a Python conference, you find people coming from all different kind of domains. So you have a lot of diversity in general represented there, which to me it's really interesting. Three things I struggle with Python are errors, because I get errors. Python has a great runtime, but if you get an error at runtime, you discover it later. Portability, because I did something cool, I cannot give an executable in an easy way to my friend who's not a programmer, or I cannot go, although it's getting better, on the most used platform everywhere, the browser. I cannot still go there natively, but PyScript is a great project. And finally, and this is a weird one, abstraction. Abstraction is the things that make us productive, especially as me as a data scientist, all the different tons of library and ecosystem. But, and I hope that, I'm really looking forward to the keynote of tomorrow of Vicky on staying close to the metal. One of the things that probably especially data scientists feel is this lack of connection with what is going on. So I really felt the need of going to concrete, not just the abstraction of programming, but really the computer, the memory, the things. Okay, so let's get to the real topic. I will have to tell something about NIM sooner or later, so I will try to say four things about NIM. First, it's an easy to learn and fast complement to Python, which has a superpower which is called metaprogramming. Second, the fact that a smart compiler and a powerful type system can give you safety without compromising expressivity. Third, that having multiple backends, in the sense of compiler backends, I will explain that, is kind of cool. And the JavaScript backend is, wow. Having one is great. Fourth, NIM is what I call a niche technology, very small community. You likely don't know anyone that does NIM. And I want to talk why should you invest about NIM, niche tech in general. I will talk about me and NIM specifically. So, easy to learn and fast complement to Python. Since it compiles natively, you can have arrays which have a statically determining length, A and B, only occupy in memory the number of bytes that are really needed, and you can do something which is really liberating, which is using freely for loops, which is something that loops are nice, are understandable. And sometimes when you have to go performance critical, you have to go through a layer of abstraction and use a library because you cannot use for loops. Second, the syntax of Python is well known for its very readable and expressive syntax. And I think NIM adds a touch of it because it works really well with the metaprogramming part. One thing that I particularly like about its syntax is something that is sometimes called uniform function call syntax, which is the fact that since at compile time you know the type of a grid, any function or proc in this case that you define on that type can be called. The NIM compiler will understand that it's called on the Python. It can be called in three different ways. As a command, show, no parentheses, G. As a method, G.show, or as a function, show parenthesis g. So no breaking print between Python 2 and 3. And finally, the superpower is called metaprogramming, which means code that generates code, which in Nim has a very clear definition in the fact that it is what happens at compile time. When you look for ways to do metaprogramming in Python, you would find, I mean, decorators are metaprogramming, the AST module is metaprogramming. Nim is very clearly defined, and it has a hierarchy of methodology, generics, which is basically duck typing in Nim, templates, which are hygienic and safe, not like C templates, ways to do copy and paste, which is great, copy and paste, and macros, which are the most powerful layer, and they are fully macros-like in the Lisp sense, that manipulate the data representation of code, which is called abstract syntax tree, and that allows you to write powerful domain-specific language, which I actually recently learned that is kind of something that is frowned upon. DSLs are very complex, or in some cases can be dangerous. And actually, this is something that in Nim did not happen to have bad behaviors like it happened with Nim. One of the reasons is that macros are more difficult to write in Nim than like in Lisp, and you should not use that power unless you really need it. Plus, the DSLs of Nim are often compile time checked, so they're kind of nice. And finally, in terms of interoperability with Python, this sort of magic and the number of libraries, there are two libraries, one called NumPy and Nimporter, which builds upon NumPy and adds more functionality, makes you do things like that. You have a Nim file, implementing, of course, Fibonacci, and you have your Python file, one next to the other, sitting in the file system, and if you have installed Nimporter, which is a Python library, and you have the Nim compiler on your machine, you can just call Python on the Python file without having to do anything else, and it can already call Nim code with basically nothing to do in between. Okay, second part of the topic is about compiler and types. I will not talk a lot about types, and Nim has a very nice type system, and I've learned that different languages have different type system, and it's interesting. You should not be scarred by compilers and type system that you've seen in other languages, and I won't mention Java or other things to say, okay, no, I don't like compilers, I don't like types. Just try other languages. So the compiler means that you can do stuff at compile time. One of the nice things that you can do at compile time in Nim is using Nim code for computing anything. If you declare an identifier as a const, you can call any type of Nim code, and this is something that will be computed at compile time. So if you really need a performant fizzbuzz, and you always need a performant fizzbuzz, you can use const before computing it, and that string will be actually, you will find it in the disassembled executable. Of course, we do not live only in compile time, so you can have variables that are defined at runtime, identifiers with values that are defined at runtime. And in order to give you a little bit more safety, there are two different degrees of that. A let identifier is something that is defined at runtime, but it's immutable later. You cannot modify it. The compiler will complain. And this helps you manage state, while the var one is the really mutable one. And dealing with state is one of the complex things, so a little bit of safety helps us doing things. This goes a little bit beyond that, because you can have so-called var parameters. So the parameters that you are not declaring as var are supposed to be immutable, and the compiler will complain if you try to mutate them, and you have to explicitly mark them as mutable, which is a very nice thing, and it's not really often used with integers, but the compiler does pointer magic behind, and you can also use it with integers. Another thing that I like very much, I started studying a little bit of functional programming, which is even safer. And one of the things that you discover is that functions are really a place where you can relax, because they do not have side effects. You just have to implement the logic, the business logic right. and you don't have to fight the language or anything. So in Nim there is these things that a compiler can do, which is called effects tracking, in which you can write on the left side proc, which can have all sorts of side effects, printing to screen, writing a file, accessing a global variable, while the func variant of this is something that the compiler will guarantee does not do anything of the above and will tell you when it does. Finally, another thing that I really like about the expressivity of the language that is guaranteed also by the static typing is procedure overloading, because one of the things I struggle a lot is naming things. And when you want an API to be natural, and you want the same thing done on different sets of arguments, you have to use a different name in Python. While in Nim, since the compiler knows about time and can disambiguate, you can use the same name of the procedure for two procedures that are defined on different types. And in Nim, it has a very minimal approach to object-oriented programming, and the syntax gives you a lot of the advantages. Okay. Third part, where I tell you about what are compiler backends, and I get excited about the JavaScript backend. So a compiler has a front end, which is basically the syntax of the part in the front, and the backend, which is the language to which it generates code. And Nim has a kind of a weird approach to this, which is very pragmatic, in which you can choose different compiler backends, C, C++, Objective-C, and JavaScript. The reason why it does that, because compiling to a target backend, you can have excellent interoperability with that language, which is also called, when you want to get fancy, foreign function interface. So Nim has very easy ways to expose something that I've written in Nim in any of those languages, but also to take advantage of libraries written in those languages. And as a data scientist who tries to do the interfaces and everything, I really love the idea of having a JavaScript backend, and this is sort of a representation of my head. Yeah, going, what can I do with this? And yeah. And one of the things that I did, indeed, is do a small dashboard. And this is something that is completely compiled to native JavaScript. So it really feels native. It's not like other things you find in Python, which actually call a server. And this is completely static code. And it's different, the feeling. OK. So, final part, why should I invest in a niche technology like Nim, but many others? We have Loris here who will give a talk tomorrow about Zig, which is also a great niche technology. Well, one reason is, of course, if you think that that technology has a promising future. But let's face it, most niche technology won't. So I want to give you 3 reasons why it's interesting to invest in niche technology, even if they do not have a promising future. One is the fact that you get easier ownership in a niche technology. So, and this will be stuff I have to talk about Nim, although I'm kind of uncomfortable about that. So ownership in the sense that you feel a lot more attached to the project and you are motivated and passionate about it. And that's a powerful driver to learn stuff. So I don't know if you have noticed, but on GitHub there are those things that tells you which languages a particular repository uses, and they have colors. And I don't know if you know how those colors are decided. There is actually a repo on GitHub which is called Linguist. And if you want to change the color of a language, you go and make a pull request on Linguist. And at the beginning, Nim has a dark green color, and the community decided it was kind of off-brand because Nim has a clown symbol, though yellow would have been nicer. And they made a pull request to have yellow. And then you discovered that there was a rule at the time that they basically removed it after we merged a pull request, that you cannot have a color too close to another language. So, with respect in closeness in terms of a particular color distance, which is called Siede 2000, which the first person made appear, I did implement the Siede color distance, and the third person generated the picture that you see on the right, which tells you which were the color available at the time. And so, with a simple inspect, we could pick a shade of yellowish orange and propose that and merge the PR, and you find the thread on the forum if you're curious about. So really, I mean, I helped pick the color for Nimib on GitHub, so that's nice. I mean, I cannot leave it so easily. So the second thing in which a niche technology is interesting is that the culture around a niche technology is growing, and maybe you can have an impact or an influence on that culture. So, there is this thing called Zen of Nim. I guess you can imagine where the idea of writing a Zen of a language came from. That is a blog post published some years ago, which, as you can see, it has a completely different style from the very playful Zen of Python. But it's also interesting in its own right. I mean, it is a different culture. A lot of the rules here are about the fact that compilers is something that can help you. And for example, if you cannot reason about code, then the programmer also cannot. So a smart compiler can really help you. And I won't discuss all the rules. There is a blog post that you can Google for it or go in the link if you access the slide. What I want to touch a little bit is about the ninth rule, which says there should be one and only one programming language for everything, and that language is Nim, one language to rule them all. So, I don't know, I like languages. I like the fact that there are a lot of languages around. I like learning languages. So this kind of rule did not really sit with me. And so I started a discussion on the forum, kind of playfully making fun of this. Not the one language to rule them all, but the one language to rule the mole, la talpa. And, well, it's not the idea of discussing where this discussion went, but the idea is that in a niche community, you can have a bigger impact on the culture. So the last thing, which is also very interesting, I think, is that in a niche technology, it's easier to do one particular kind of open source. I mean, I think that Python is really friendly to open source contribution in lots of ways, but I've never felt the need of making my own Python library, because I have everything at my disposal, and for the work of data scientists, I didn't really need that much. I mean, I think there is a high bar in Python in terms of skills in order to do your own library, while in a niche technology, the ecosystem is small. I mean, you can give your contribution more easily. And so that's what I did. I did my library, so since I was a data scientist, I like working with notebooks for the output, not really for the state. There are better notebooks, as Luca knows. And so I invented this library, which is a literate programming library. And it's really, I think, a different take on literate programming, as the library is not very common, in which you write some code, DSL, you might say, you compile and execute, and you have a HTML page. I don't need to zoom because you don't need to read too much. And, sorry. Oops. Okay. And you can do then all sorts of things with that. For example, the slides that I'm doing, I did it with another library built on top of this, thanks to Hugo, who might be watching this. Hi, Hugo, who is a person I met in the Nim community who was sharing the vision for this library, and so we became co-designer and co-maintainer of this. And then at some point I even went and said, okay, but maybe this also makes sense for Python. And since I have interoperability, I created an API more Python idiomatic, although I'm still iterating on that does this. And you cannot yet pip install it, and produces the same thing. And of course, the first thing that I applied it to was Advent of Code, because Advent of Code is the first thing that I did with Nim, and there is a panel right after this session, right here on Advent of Code with other friends from the Python world, which is also one of the reasons for which I will not be available for much time for questions after this, but please come find me later after the panel or tomorrow. So, what are the conclusions? The idea is that to improve as a programmer and as a Pythonista, maybe learning a new language is an interesting idea, and maybe also doing things in an uncomfortable domain is a good idea. I tried to give you reasons why you might be interested into Nim, which is, I would say it has a lot of unexplored potential. And I think the Python community is one place where it could have a lot of interest, but you can pick a different one. And the other thing I try to convince you is that maybe not Nim, but maybe another niche technology could be interesting. And there is Zig, there is Glim, Rock, whatever. There are a lot of great languages with great projects coming around that are really, really interesting. But still, if not, I mean, go learn JavaScript and you can do front-end stuff. So, that's the end of the talk, and I want to leave you with this quote, which through this journey of learning Nim, being a bit involved in the community, a lot of the things that I did was also comparing with the Python community. And one of the things that I discovered is, at some point, this quote by Guido, which I think it's a great quote, and sometimes we take for granted what we have here in this community and what Guido did for the language. And this idea that the most important idea in Python is not really a technical thing, but the fact that it is a language developed entirely in the open by volunteers, which are actually professionals who feel passion and ownership, is a really powerful one. And I think it's one of the ideas that, for example, is trickling. I mean, the niche languages that I also like kind of share this. So languages are not always born with a BDFL. They are born also from an enterprise. And that's fine too. But this idea is a very powerful way to build a language and a community, and it's just great being here. Thank you. I will stop and I will open up for questions if you have some time.
Okay. Thank you, Pietro. So there are some questions in Slido. So I would like to say these questions. Yeah. So what are some
real-life use cases for Nim? So let me start by places where, for example, Nim is used in production. I will pick maybe less useful. One place where it's used in production is a place which is called Exercism, which is a place for studying programming languages. And one part of the tooling there is actually done in Nim. And I love Exercism for all sorts of reasons, so that's one. Then let me quote another one, which is Chalk, which is an open source startup in the security domain founded by John Viega, who was one of the early adopters of Python, who recently grew an affection to the language and built a company with that. Then it's two other relevant places are Web3 stuff, or it's used in a team of analytics at Reddit, where there are two people that are putting great libraries out, and
Okay, next question.
Games also.
I have been using Nim for quite some time, and I have not found a pleasant way to do thread parallelism in the same way yet. What do you recommend?
Okay, so that's not one of the parts. I'm a little bit out of my comfort zone, but parallelism was something that is kind of a sore point for a while. Recently, there is a new library that the creator of a language made, which is very powerful. Which is called Malebolgia, and because it spawned threads. And then there is also a server made by the team at Reddit, which is called Mummy, for the ancient art of threads, which, if you need threads in the content of servers, seems really powerful. It's running in production with a very, very powerful way.
Okay, another question. What error would compiler throw in case of an error in the code?
It depends on the error. It might be type error, syntax error, like in Python. And this is something that, for example, in terms of programming languages, Nim, since it has this very flexible type system and metaprogramming, I would say they are not the best kind of level of compiler messages. They are not Elm level, which was actually the originator of the compiler, inspirator of the compiler messages in Rust, which maybe more people are aware of.
Okay. Do you like Glim?
Yes, I do. I love it.
Does Nim have a package manager? How does it handle distribution on the different backends?
Okay, yes, it does have a package manager which is called Nimble, although now there is also another option called Atlas for various reasons. Nimble started trying to mimic a little bit of Cargo, and it's one of the things that is very easy to publish packages because it's also distributed. The thing about different backends is that you can say when in the code, you can say when JavaScript or when the backend is C, and you can have different type of code with respect to the different backends. So you can have library which can be used for multiple backends, or you can error out. So it's just Nim code. It's just you have compiler guards.
That's it. Thank you, Pietro. And
thank you, everyone.